The objectives of Module 3 are to explore the principles behind tidy data, explain methods for handling and cleaning messy data, describe techniques for data manipulation and optimizing grouped analysis. Data preparation is a crucial step in the data analysis process. It involves cleaning, organizing, then structuring raw data to make it ready for analysis. In this session, we will explore key aspects of data preparation, including working with tidy data and understanding how to structure data efficiently for analysis. Handle messy data. Manipulating and transforming data, learning techniques to clean and reshape datasets. Optimizing for grouped analysis, gaining insights from grouped data by summarizing and transforming it effectively. Let us explore them. Introduction to tidy data. Welcome to Introduction to Tidy Data. Tidy data refers to datasets structured for easy analysis. For example, a dataset of student grades where each column represents a variable like exam or grade, each row represents one observation, and all values are neatly organized. Tidy data ensures clarity and makes analysis efficient. Work with tidy data. In data analysis, organizing your data efficiently is crucial for effective analysis and modeling. Tidy data refers to a standardized way of structuring data that makes it easy to work with, analyze, and visualize. The concept of tidy data was popularized by the data scientist Hadley Wickham and follows a simple yet powerful principle: data should be organized in a way that facilitates its use across various analytical tasks. Principles of tidy data. 1. Each variable forms a column. Every column should represent a single type of measurement or variable, e.g., age, income, temperature. 2. Each observation forms a row. Each row should represent a single data point, such as a specific individual's record or a transaction. 3. Each type of observational unit forms a table. Different entities should be stored in separate tables, e.g., separate tables for customers, sales, products, for clarity and consistency. Tidy data allows for easier manipulation, aggregation, and visualization, making it a critical skill for anyone pursuing a career in data analysis or data science. By organizing data in this format, analysts can save time, reduce errors, and ensure that the data is ready for use in advanced statistical analysis or machine learning models. Handle messy data. In data analysis, messy data is a common challenge that can significantly slow down analysis and lead to inaccurate conclusions if not handled properly. Understanding the difference between tidy and messy data, and learning how to clean and transform messy datasets, is crucial for anyone working with data. Visually appealing but messy data. Some datasets may appear organized but are messy in structure. For instance, a table with merged cells for student names and exam scores may look neat but is hard to analyze. Messy formatting like this creates redundancy and misalignment, making the data difficult to work with. Messy data versus tidy data. Messy data often includes issues like merged headers or combined data types in one column. For example, a messy dataset might have exam results in rows with multiple scores crammed into one cell. A tidy version would separate those scores into individual rows and columns with clear labels for each variable. Excursion, a messiness from redundancy. Redundant data occurs when repeated information clutters the dataset. For instance, having a student's name repeated in every column or row. The solution: normalize or restructure the data. By separating names into their own column, you reduce redundancy and improve efficiency. Tidy or untidy. Here's a made-up dataset to evaluate. Notice how some rows contain multiple observations and fields have multiple values. This is untidy. To tidy it, ensure each row contains a single observation and all fields hold just one value. Manipulate and transform data. In data analysis, one of the most important tasks is transforming your data into a format that is easy to work with and ready for analysis. Data manipulation and transformation allow you to refine your dataset, extract meaningful insights, and prepare it for advanced techniques such as statistical analysis or machine learning modeling. Key data manipulation techniques includes filtering rows, selecting columns, pivoting data, adding new variables, creating derived variables, mutate, adding or modifying columns, then summarizing data. Let's explore them. Pivoting longer. Pivoting to a longer format means combining multiple columns into one. For example, instead of separate columns for midterm and final scores, we pivot to a single exam column with another column for grade. This structure makes analysis easier. Pivoting wider. Pivoting to a wider format is the opposite. Imagine a single column with exam types, midterm, final, and their grades. Pivoting wider spreads the exam types across distinct columns, allowing a clearer view of each student's scores. Filtering rows. Filtering rows focuses on relevant data. For example, a dataset of grades could be filtered to only include rows where grades are above 1.7. This helps you analyze only the data that meets specific criteria. Selecting columns. Column selection narrows the focus of your analysis. For instance, if your dataset includes extra columns like age or classroom, you can select only exam and grade to streamline your analysis. Tidy specification of columns. The Tidy Select package simplifies column selection. For example, you could use Select to choose columns starting with the exam or containing grade. This saves time and keeps your workflow tidy. Adding or changing columns. Add new columns to enrich your data. For instance, create a past column where scores above 1.7 are marked true and scores below are marked false. This enhances the dataset's value for analysis. Renaming columns. Renaming columns improves clarity. For example, rename a student column to participant for better readability and consistency with your project's terminology. Splitting columns. Splitting columns organizes data further. For instance, split a results column that contains homework 1, homework 2, homework 3 into separate columns, one for each homework assignment. Sorting. Sorting organizes your dataset for easier analysis. For example, sort a table of student grades by name alphabetically or by grade in descending order to quickly identify top performers. Combining data. Combine multiple datasets into one. For example, merge a table of midterm results with final results using bind, or join additional student number data with exam results using full_join. Optimize for grouped analysis. In data analysis, working with groups or subsets of your data is essential for uncovering deeper insights that might not be visible when analyzing the entire dataset. Grouped analysis allows you to focus on specific categories, time periods, or segments, helping you identify trends and patterns unique to those groups. Grouping data helps optimize your analysis, especially when you're working with large datasets or need to perform segmented evaluations. Grouped operations is summarize. Summarize grouped data to calculate statistics. For example, group grades by student and calculate the average score for each using summarize. Grouped operations, mutate. Use mutate to modify grouped data. For example, add a student_min column to a dataset calculating each student's average grade across all exams.